Okay. So what we have here is just function pointers, and really it's just going over a kind of a concrete example. Now, this example is pretty trivial. This is pretty much pulled right off of what Fox has on his lecture slides. So it's trivial for a couple reasons. One, this is kind of a lot of dealing with function pointers for something that we could just not use function pointers and get kind of the same behavior out of. The other reason it's super trivial is because this function is called sort stuff, and I'm not sorting anything at all. I didn't feel like writing a sorting algorithm, so I didn't do that. Um, so really, if we kind of walk through this, I kind of explain what's going on. So we have this function right here called sort stuff, and it's going to take in two numbers and then a function pointer, which we'll go over the syntax of this in a second. And then really the only thing it's doing is just calling the compare function, which is the pointer that we're passing in on the A and B integer that's being passed in. If you take a look at his lecture slides, what his sort stuff function is actually doing is using the compare function to sort his numbers in a certain way, right? Where this is taking in a vector as opposed to two numbers. Um, so really here, my sort stuff function is just returning the value of whatever compare function I pass in, right? But this will still prove the point of why function pointers are cool to use. So the next three functions I have here are all pretty much the same thing. They take in two integers, A and B, and then we're going to return the value of the symbol here, right? So for ascending, if A is bigger than B, we're going to return true, false otherwise. For descending, we'll return true if A is smaller than B and false otherwise. And then equals is just if A is equal to B, then we'll return true and false otherwise. So down here in main, we have two integers, A and B, that I made 10 and 7. And then we go ahead and call the sort stuff function three separate times. The difference in all of them is the function that I'm actually passing into the parameter. So this is what's new and something that you guys haven't seen, where we are actually passing in a function as a parameter, right? That's kind of weird and seems a little backwards to us. But what we get out of this is this sort stuff function actually takes in a function pointer. So looking at the syntax of this, it's going to take in a function that has the return type of Boolean. So all of these do. It has the pointer syntax, so the star and then whatever the name of the variable that we want to name it. So we're just calling it compare. And then the two values that the function pointer is going to take in. So all of these match in, right? If we had another function out here that didn't match the return type or didn't match the parameters, we couldn't use that. We couldn't pass that into the function. Hopefully that makes sense. Things need to match up with the return types and things need to match up with the parameters themselves. So what's cool here is this sort stuff function is actually going to use the behavior of whatever we pass in, whatever function that we pass in. So if we go ahead and run this, not a lot to really look at, but we know that A is bigger than 7. So on the first one, which is ascending, it's going to return true for A is bigger than 7, or excuse me, A is bigger than B, right? So that is true. That's what the 1 is. The next two are going to be false because we use descending. A is not bigger than B, so we get false there. And then for the equals, A is not equal to B, so we're also going to get false here. The main takeaway from this is just that we are able to pass functions around and actually use functions inside of other functions through the pointer, right? And then we can point to different functions and pass that pointer around. Because really, we're not passing a function around, we're passing a pointer to a function. So that's kind of the idea here. I guess, are there any questions on that? I know this wasn't super in detail. Like I said, you don't have a lab, and the final should only have a few questions on this. So what
Yeah,
are your
so
questions? Yeah.
so real quick. So the first time you called it, basically, your function, right? You're basically putting in it's getting the memory address, right, of a
Hmm.
function. So
Hmm.
then it kind of you don't have to explicitly dereference it, but it does that inside the function, right? So then it
Hmm.
gets the function that's in the memory address. But then when you call it the second time, um, it kind of does that like look, when you call them descending, before you call it, is ascending right now in that memory address or no?
Um, yeah, good question. So the idea here, 'cause, yeah, that's a pretty good question. So when we pass ascending in, and this is when you kind of have to picture like stack frames. So all of these functions, like the actual instructions for these functions, so what these functions do, are all put on the stack, right? And they each have their own memory address. So if we printed out one of these functions, and maybe I can do that to make this a little bit more clear. Hopefully this works out the way I expect it to. Um, this might just yell at me. I might not be doing this right. That actually just prints out one. Let's see here. Try this. Okay. Yeah, that's not exactly printing out what I'm
Yeah, you're
expecting
trying to
it
show me
to.
how like the memory address changes of ascending.
Yeah. So like I can do. You're talking about printing it out in here. Let's do compare should just be a memory address. So when we do this, um, hmm, if anybody knows what I'm doing wrong, definitely let me know. I'm expecting to get memory addresses from this, and I'm not. Let's see here. I
Oh,
don't
I think
think.
it's I think it's because we learned in class that it does nothing when you're using what's called the function pointers. The ampersand is useless. So you
Okay,
just
Yeah,
have to.
Franco's
gotcha.
right. Yeah.
Okay, yeah. And then when I do the ampersand here on the compare, that's just the actual compare variable
Yeah.
and not referencing any of these. So that's why it's the same here every time. In that case, I don't know exactly how I can print out the ascending, descending, but all of these do have their own memory address. And when we pass it in here, compare will basically point to a different memory address. So if we kind of walk through this and talk about like line 26, when we pass ascending in here, compare is going to point to wherever ascending is like on the
Mhm.
stack. Um,
Yeah, but technically, yeah. So it does that even though it's yeah. So and then since it's a pointer,
mhm.
it's not gonna be really passed by value. So before line 27 starts, compare, even though it technically kind of only exists inside of the function, it
Mhm.
will be pointing to ascending. But then you're passing in ascending, descending, so then it's gonna point to descending. It's
Um,
just like
Kinda. I think the only difference is that when this actually pops off the stack, so not the definition of the function, but the actual memory associated with this compare variable, that memory is going to pop off the stack. So at that point, compare isn't actually pointing to anything, because
okay,
compare doesn't actually exist anymore in
okay,
memory.
yeah, that
Does that
makes
make
sense.
sense? Okay.
Because it only exists inside the function, so it just pops off.
Yeah, exactly. Because this line is basically the same as doing something like, more or less doing something like um,
Yeah.
this, right? And this is actually happening. Like this line is happening when you call this function. So then when the function terminates, all the memory for this is going to get popped off the stack, which means that pointer doesn't really exist in memory anymore. Um,
Yep.
so yeah,
Yeah.
that was a really solid question.
Yes. But if you had this compare whatever, if you created
Mhm.
a function pointer in main, right?
Okay.
Then you pass it in or whatever you mess with it, then it would change, right?
Yes. So if you're saying doing something like this and then
Yeah.
passing compare in, um, yeah, this would be basically have the same behavior now. But yes, then if like you passed compare in each
Mhm.
time here, then obviously it'd be pointing to the same thing each time,
Yeah.
and it's just going to do ascending every time.
Yeah.
Yep. Yep. And then you could do obviously something like this where it's like no, I want this to be descending now.
Mhm. And
So
then either way, these functions only work if you pass in the same type, right? So you're gonna have to pass in an int function, right?
yeah, correct. So if we did something like does not equal, and we did an a and b and c, I think this will work, or not work rather. We can just do, so like it's defined correctly as far as this is concerned, but like it has an extra parameter here. So let's see what this will do if we try to do um, does not equal. Yeah.
Yeah.
So it basically gets pissed because it doesn't match the parameter. So if we went ahead and nuked this, this should return true when we run it because they're not equal.
Yeah.
And kind of what I just did here is kind of the idea behind these function pointers, where we didn't really have to touch any other code. We didn't really have to touch the definition of sort stuff. We could just mess with a different function and then pass that function in. The most common place I've seen this is working with like different APIs or different pieces of code that maybe like your instructors give you or professors give you, where they've made a function like this, where it does kind of some relatively complex stuff, and it's your job to basically fill in the blanks with a whole other function that you can define as a function pointer. So that's kind of a concrete use case I've seen for it. I think it was with a sorting algorithm actually. So yeah, good questions. Any others? Okay, cool.